Let's look at probability, theoretical probability. We're playing Monopoly. We already have Boardwalk, and we want to buy Park Place. We need to roll a 9 in order to land on Park Place. What's the probability that we roll a 9? Well, first off, what is probability? Probability is a number between 0 and 1 that we assign to the likelihood of a particular event. We will use the symbol P of E to represent the probability that an event E occurs. If E is impossible, then the probability of E is 0. If E is certain, then the probability of E is 1. For instance, we roll a 6-sided die. Find the probability that we roll a 2. Well, here's the principle we use. Suppose there are n equally likely outcomes that are mutually exclusive. In other words, 2 of them can't occur simultaneously. That's what we mean by mutually exclusive. The probability that a particular outcome occurs is 1 over n. So in this case, you have 6 outcomes. They are mutually exclusive. You can't get a 3 and a 4. You just get one of those outcomes. You have 6 equally likely, mutually exclusive outcomes. The probability the particular outcome occurs is 1 over n. In this case, since there are n outcomes, n equals 6, the probability that one of them occurs is 1/6. We roll a 6-sided die, find the sample space. Sample space is, in other words, the set of all possible outcomes. That is 1, 2, 3, 4, 5, 6. That's what we mean by the sample space. It's the set of all possible outcomes. We randomly pick a card from a deck of 52 cards. Find the probability that we pick the ace of diamonds. Again, we're going to use the same principle. Recall that a deck of 52 cards consists of 4 different suits. You've got heart, diamond, club, spade, each with 13 different values. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So in other words, you've got 4 times 13. In other words, 52 cards. That's just a reminder for those of you who don't do much with cards. Again, we use the same principle. You have 52 equally likely outcomes that are mutually exclusive, so the probability that a particular outcome occurs is 1 over 52. Probability of an ace of diamonds is 1 over 52. Now, let's find the probability that we pick an ace. Not just the ace of diamonds, but the probability that we pick an ace. Here's the other principle we'll use. That, as you might expect, is 4 out of 52, because there are 4 aces. Here's the principle we're using. Suppose that all the outcomes in a sample space, in other words, all possible outcomes are equally likely, and that E is an event in that sample space. The probability, in other words, the theoretical probability that E occurs, is the number of favorable outcomes in the sample space over the total number of outcomes in the sample space. That's a lot of verbiage, but I think you'll understand it. In this case, how many possible outcomes are there? The total number of outcomes is 52. That's the number of possible cards that you could pick. And how many of those 52 outcomes are favorable? In other words, well, in this case, we want to calculate the probability that we pick an ace. So how many of those 52 outcomes involve picking an ace? That would be 4. So that would be the number of favorable outcomes, 4 out of 52. We roll a pair of dice. Find the probability that the sum is 9. Well, for this one, again, we would use the same principle, but we need equally likely outcomes. Somehow, we need to take the roll of a pair of dice and separate that into equally likely outcomes. Here's the way we'd go about doing that. Consider the first die and the second die. You've got 36 possible outcomes because you have 6 possibilities for the first die, 6 possibilities for the second die. Each of these 36 outcomes is equally likely, and thus has probability 1 over 36. The probability of getting a 2 is 1 out of 36. The probability that the sum is 3 is 2 out of 36. Probability of 4 is 3 out of 36. 5 is 4 out of 36. Probability of rolling a 6 is 5 out of 36. Probability of rolling a 7 is 6 out of 36. Probability of rolling an 8 is 5 out of 36, a 9 is 4 out of 36, a 10 is 3 out of 36, an 11 is 2 out of 36, and the probability of a 12, boxcars, is 1 out of 36. So the probability that you roll a 9 would then be 4 out of 36. So notice we've got this over here, 4 out of 36. Oops, sorry about that. That's the probability that we roll a 9. Let's say we flip a coin 3 times. Find the probability that we get exactly 2 heads. Now, you might think this way. The possible outcomes are 0 heads, 1 head, 2 heads, 3 heads. There are 4 outcomes, so the probability that you get 2 heads is 1/4. Yet if you experiment by flipping a coin repeatedly, you will find that this answer is incorrect. The probability of getting 2 heads is not 1/4. It's more than that. What went wrong? Well, what we need to recognize is that we need equally likely outcomes. The outcomes 0 heads, 1 head, 2 heads, 3 heads are not equally likely. Somehow we need to break up the outcomes into equally likely outcomes. Here's the way to do it. So we need to find a way to express the outcomes as equally likely. We'll do it this way. On the first try, you can get a head or a tail. Second try, you can get a head or a tail. Third try, you can get head or a tail. So here are the 8 outcomes: HHH, HHT, HTH, HTT, and then THH, THT, TTH, TTT. Did we get them all? Yes, because there are 2 outcomes in the first case, 2 outcomes in the second case, in other words, for the second flip, and then 2 outcomes for the third flip. So 2 times 2 times 2 is 8 possible outcomes. We have listed them systematically so that we didn't miss any of them. Each of these occurs with probability 1/8. They're all equally likely. And the probability that we get exactly 2 heads is 3/8. Because notice these are the only ones that involve getting 2 heads.